Okay, so we have here, it says a graph of f prime of x is shown. So we're assuming this right here is f prime of x. And we're being asked to give a possible rough sketch of f of x. So basically it's asking us for one of the antiderivatives of this function. And so, you know, pretty much what we're doing is the same thing that we did when we graphed derivatives, just backwards. So let's take it, you know, one at a time. Here, for example, so because the derivative is equal to 4, so that means that positive 4, that means that it's going to be your function from 0 to 4. It's going to have to be, so here it's positive from 0 to 4. So that means that it has to be increasing, right? Okay. Now remember, your antiderivative could start anywhere along the y-axis as long as you don't have any information about your function. So, you know, let's just say we start it here, and so we just say that it's going to start going up like that. Okay, now for this second part, let's sort of break this down a little bit. So from here to so from 4 to 7 in that section, notice that it's positive, and then right here in this section it's going to be negative. So what that means is that from 4 to 7, right here is 7, since it's positive, then it's going to be increasing. And then over here, since it's negative from 7 to 10, then that means that it's going to be decreasing. Okay, but then there's another aspect of this, and that is that throughout this whole time, the derivative is decreasing. Right? And what does that tell you? This is going to take take you a step back a little bit, but that means that throughout this whole period right here, your original function, or your antiderivative, is going to have to be concave down. Right? Because if, so let's try to work through this thought process. If this one is decreasing right here, like it is, then its derivative is going to be negative. In other words, the second derivative is going to be negative. So if the second derivative is negative, then that means that the original is going to have to be concave down. Okay, so after this point right here, it has to be increasing, then decreasing, and concave down. And so again, increasing, decreasing, and concave down. Something like, you know, something kind of like that. And that's it. Okay, so we're going to try to graph the antiderivative of this function. So let's break this down by section. So we're assuming that this is f prime of x, and this is, oh, sorry, not f, g prime of x. That's the same thing, but okay, g prime of x, and then this is g of x. Okay, so let's break it down one step at a time. Remember that, let's break down the positive and the negative aspects of it. So here, because it's negative from 0 to 2-ish, that means that this one is going to be decreasing. Okay, so we're just going to break this down step at a time. Now here, the derivative is positive, which means that our function would have to have been increasing. Okay. And then the last part, again, negative, which means that our original function would have to be decreasing. Okay, so that's where we're gonna split up the increasing and the decreasing aspects. Now the other part of it is the concavity. Now to take a look at that, we need to look at whether the derivative is increasing or decreasing. So notice that for this whole section right here, our derivative is increasing, which means that your original function would have to have had been concave up. So it has to look like that. And then for this last section right here, it's decreasing. So that means that for this section, your function would have to have been, the original function would have to be concave down. And so then, you know, that's pretty much all we needed to know. Because here it's concave up and decreasing. And again, remember, since you don't have any initial information about your function, you can start it anywhere on this axis. So I'm just going to start it up here. So what color should I use? How about green? So it's going to be decreasing, concave up, increasing, sorry, decreasing. Did I say increasing? I meant decreasing. And then right here at this spot, it's going to start increasing, but still concave up. But then halfway around here somewhere, it's going to start becoming concave down, or in other words, has an inflection point. And then here, it's going to be stop increasing and it's going to start decreasing, but still concave down. And that's it. Okay, so we're going to use the graph down here to find all of these integrals. So let me put it in bigger numbers. This one is 12. That's not very good contrast. 12. And this one is 2.5, and this one is 5. Now, these numbers that's the area in absolute value. So like even though this one, it says 2.5, you know, if you get the integral from b to c of this function, it would be negative. Okay, so now the first one says, okay, what's the integral from a to b of f of x dx? Okay, so from a to b, well, that integral is simply 12. Okay, that's easy. And then again, the one that I just said, from b to c, that is negative 2.5. Okay. And then from c, oh no, sorry. From a to d, so that's from a to d, so that's the entire thing. Well, this is going to equal to 12 minus 2.5 plus 5. Because this one is going to be negative, right? Okay. So this is 17 minus 2.5, that's 14.5. Okay, now the integral from a to c of f of x, so from here to here, well, that's 12 minus 2.5, which is simply 9.5. Okay, and then I have the integral from a to c of the absolute value. Okay, so now we get gets a little tricky, because we're going from c to a of the absolute value of f of x. Okay, now I think I'm going to need a little bit more room here for this one. I'm going to bring this one over right here on the side. So I'm going to do integral from c to a absolute value of f of x dx. Okay, now one of the really important aspects of this is that when you're reading the area underneath the curve from a graph, it always has to be going from the smaller number to the bigger number. And here notice that it's backwards. So because it's backwards, it's going from bigger to smaller, from C to A, you can't read it directly from the graph. Now you don't have to worry about this when you're using the fundamental theorem of calculus, because it's all built in. But when you're looking at it from a graph, you do. So this is equal to negative the integral from a to c. You have to use that property to switch the limits of integration. Okay, and then now you can find the integral from a to c. And then since it's absolute value, this is going to be minus, and then it's going to be 12, and then this one that's negative, it's going to basically be bounced up here, so it's going to be positive area because you're talking about the absolute value of f of x. So then, but you have this negative sign out here, and so the answer is negative 14.5. And this is totally counterintuitive because, you know, in the beginning you're like, oh, well, absolute value, it's going to end up being positive. But because you have to use the property to switch the limits of integration, then it actually is a negative value. Okay. Now the next one, again, from d to b, you have to flip it, make it from negative b to d of f of x dx. And that is going to equal to, now this one you do count it as, this 2.5 as negative. And so it's going to be, so you have 5 minus 2.5, that's 2.5. But then you have this negative sign out here. So this whole thing is going to be negative. Okay. And then now this next one, from a to d of the absolute value of f of x. For that one, simply you just add all of them from a to d, but they're all going to be positive. So it's going to be 12 plus 2.5 plus 5. And that's going to equal to 19.5. Okay, and then this one is the same. From b to d, that's 5 plus 2.5. That's going to be 7.5. And then from d to c, again, you have to flip it. Negative from c to d, f of x dx, and that's equal to negative from c to d is 5. And that's it.